Hello and welcome to another video. This video concludes the trilogy in which we've been exploring the Bifrost graph. In the first two videos, we explored how to use the graph and get nodes together and connect those nodes up in order to get the graph working. Then we explored how to build a specific effect and then create compounds so that we can actually publish that effect and distribute it for future use, either in another scene or maybe to a wider audience. In this video, we're going to take the same effect, the same compound, and we're going to explore it a little bit further and see how we can develop and enhance it. And we're going to explore how to add custom properties to objects and get those into our graph, and then how can we repackage it up even further. Okay, so to start things off, I've just created a very simple graph here using the original push deformer that I've been building throughout these videos. And we've got our object all working and our deform works perfectly well. What I want to do now is explore the possibility of expanding upon this deformer and adding some more capability to it. And what I want to focus on is providing the ability to maybe apply the deform on part of the mesh and not the entire object like we do so now. Now, the way I'm going to do that is by using a vertex color map, which is really just a texture map in a way, a weight map, or even a displacement map. And the reason for choosing this method is I think it gives a lot of flexibility for this deformer because it's agnostic, really. It can be applied to any polygon mesh. A color map can be applied by anybody. And also it gives the ability for the user to actually paint on exactly where they want the deformation to occur. So that's why I'm going to use it. Now, before we proceed, we need to think about how we're going to do this. And we have our original push-up here. And now this is a compound, and we've retrieved that compound. And we can't edit the compound because this little blue icon is telling us that. And if we go into the compound, it's telling us that it's referenced. Now, of course, you can change this by selecting the compound and going to the edit menu and choose make compound editable. And you can choose to then change it. However, I want to keep this compound as it is because if I make any changes to this now, I'm going to have to publish it out under a new name or just publish it again and it will overwrite the existing one. I want to have some flexibility and I want to keep the original push-up for maybe future use. So I'm not going to really edit this compound. What I'm going to do instead is explode the compound out, and then this will give me the ability to build up a new graph with the new option that I want, and then I can maybe create a new compound from that. Okay, with our compound exploded, we can now turn our attentions to creating the vertex map. Now there's a couple of ways to do this. You can simply right mouse click on the mesh, scroll down to paint, ignore paint select and ignore 3D paint. You want mesh here. This will give you two options. You can put in a face color map or a vertex color map. Now, if you've never done this before, this might be a little confusing for you. So instead of choosing this option, instead go down to color set and bring up the color set editor. And this will give you more flexibility and control in creating a map, renaming it and then painting it how you want. So if we select new, this will bring up the options for creating our map. The first option is color range, and that will mean if you have it clamped or unclamped. By clamping it, it means that all the values will stay within the 0 and 1 range, which I think is personally beneficial, and that's what I'm going to go with. Then you can choose which type of map to create. Do you want to go with RGB map, an alpha channel, or an RGB and an alpha channel? I'm just going to choose RGB for now. The other options, we can ignore those completely. If you get stuck here as well, remember, just choose the help option here, and this will take you to the specific help page related to these options. So let's choose apply and close. This will now apply that color set property onto our mesh straight away. It's already there, the property is already there, but we now need to define some values for it, and that means painting some values. So we need to bring up the paint vertex color tool. Again, we can do it from the right mouse click menu here, or go to mesh display and bring up the paint vertex color tool here, or just do it through the color menu here. Now you're going to want to bring up the options as well because there's a few things to be mindful of before you start painting. The first thing is the type of operation. So this is what it is you want the actual painting to do. In this case, you want to add a color. We want to add a color to this map. You can choose to remove it and smooth it off as well. Next is the paint kind of mode, you might say, is to how do you want the color to be applied. So we've got it set to vertex, which basically means it will apply the color onto the actual vertices. You can choose to do it per face, or even do a hybrid of vertex face. It's really entirely down to you. Then you've got channels. We only chose RGB, so only RGB is active here. The other two are grayed out. And then of course you've got the color value. So we're just going to choose white, and we're just going to paint. And remember, you can change the brush size by holding down the B key and just middle mouse click and dragging. So that's all I'm going to do now. It's nothing too fancy. It's just for this example. So that's it. I don't need to do any saving or updating at all. As soon as you paint a value, it's automatically applied to the actual map. Now, before I move on, I want to rename this as well and call it something a little bit more descriptive. So I'm just going to call it weight map 01. And that's it. Close that down. Now we can turn our attention back into our graph editor, and we can start looking at our graph to bring in that property. And we need to bring up our watch point, and when we do so, we can see at the very top is our new weight map property, and you'll see it appears just like a property, like all the other properties. We've got a name, we've got a data type, and also default values, etc. And you'll notice it's the same type as our point positions and our normals, because it's applied to the vertices, and we know there's 400 of them. It's also an array, which basically means it's like a list or table of data. Each vertice will have an RGB value applied to it, and those values are 3 float values, 1 for each channel, R, G, and B. So now we've got that property, we can bring it into our graph. So how do we do that? Well, we take the same approach that we did with the point positions and the point normals. And again, now we've got a little bit more knowledge, we can start to understand how Bifrost works. So instead of guessing, we can apply the same logic. So we need to get the data in. So maybe a get node might work, because if you were to try and search for something, you would become very stuck. If you put in color, for example, there's not a node there. If you were to put in vertex, for example, there's nothing there either. Even if you put in paint, that's not there. If you put in set, like a color set, well, that's not quite right, because this brings up the set nodes, and that's about setting a property onto an object, not necessarily getting a property onto an object. So what we need to do is actually bring in the get nodes, but also what node do you actually get? There's loads of get nodes here. So again, you could look at maybe property. So if you shortcut by property, then you can say, well, if you combine the word get with the word property, then maybe you've got some options here. So we've got the first one is get geo property. We've got a get property and a get property any. So which one do you use? And for me, it was trial and error. So I chose get property to begin with. And again, this brought it into my graph, into the editor. And I looked at the info, and this seemed to work. It gets a property from an object. But when I started reading through this, it didn't really make any sense. When I tried plugging the mesh in, which I could do, no problem, it was asking me for default and type, and I didn't know really what that meant. So this didn't really seem to match anything. So even if I was to match this against the data type, where do I define the weight map? It didn't make any sense to me. So that was obviously the wrong node to choose. Then I tried another node, another get property node, which was get property any. And again, this was a very similar thing. Looked at the info. Then it said, mentioned things about amino, and if the property doesn't exist, empty amino. And I thought, what's amino? That doesn't sound right either. So that's perhaps not the right node to use either. But until eventually I settled on this node, which was a get geo property. And again, this was through trial and error. I was bringing in nodes, I plugged them all together, they didn't work, and then I thought, well, I've got to start again. And this was something that this node was a lot more akin to what I was trying to do, because again, in the info panel, this said, first off, it returns the array of values of a property. And we know that the property that we're looking for is an array because it's telling us that here. And then it says, obviously, it's on the components on a geometric object, which is what our torus is. So this was looking a lot more positive. But first off, they looked at the ports. So the inputs are geometry, property, and type. So first off, we plug in the geo. They're like so. That's now taking all the data, all these properties that we've got listed here have been driven into this node. And now we need to define the properties. What's the name of the property that you want to get from the actual object? And we need to put that here. There's no way to pick it. I can't do a little eyedropper and then just pick the property I want, which is slightly frustrating. There's no copy and paste either really here, which is again very frustrating. So the simplest option is to just type it in, which is okay, but can be prone to error. So that's fine. We've added that in there. And of course, we notice now the top of our node, this name now appears. And then we set the type. So this was really setting the type of the property. And when you select this menu, you've got some suggested types here. And it's all about just matching it up against what's already in your watch point. And we know that it's an array and it's got math float 3. So we can just scroll down to this option here and choose that because that matches our data type. And then our node changes. It doesn't produce an error anymore. And we can now continue with the workflow. Now we've got our property in our graph. What do we do with it? Where do we plug it in? Well, the area we want to focus on is down here because this is where the multiplication is kind of being done. If you remember, we got the point positions and the point normals up here, and then we were channeling the point normals into this multiply node. And what we were doing, we were multiplying the point normal values by a single value with this node. And then the output of that sum or that operation was then being pumped out here and then added to the original point positions of our object. And that's what made our object expand out. So what we need to do now is somehow bring this property into this equation. So first off, let's unplug. So we could experiment here. We could unplug the point normals, for example. So if we just do this and plug in this data here, what happens? And that appears to work. We've got a slight deformation there appearing. The original object seems to be intact. So now if we were to scale our value, what happens? So we get some deformation, but it's not performing how we want it to. And we get a really odd shape. And yes, it's deforming the mesh, but that's not what we want. We want the object to stay in its position and only the part that's painted to be deformed. And we want it to be deformed in the same way that we had before. So we need to find a way of keeping that object in its place. Now, if you remember what's happening here, we're taking the weight map values and multiplying it by a single value, and then we're adding those values onto the original point positions. We're not using the point normals at all, whereas the previous deformer or the previous operation was. So we need to maybe retain these point normals and instead use these to drive the deformation combined with the weight map. So let's try that. So if we were to unplug everything here, so in this case I'm going to put this value here, so let's put the point normals back here, and then this time we're going to take the point normals and multiply them by these values on our weight map. And when we do that, that looks something that's a lot more what we were hoping to try and achieve. We've got part of the mesh is being deformed and only the part that's painted white is being deformed and everything else is black, although it looks a bit of an odd shape. But we've got the deformation working. That's the first stage. The second stage is how do we control that? Well, we can just bring in this multiply node back in again and use this to control it, because essentially all we're doing is we're multiplying all these values together. So first off, we're multiplying these two values together, but then if we bring in this third value, if we set this down to say 0, nothing should happen. So if we do this, that will go back to normal, because remember, we're multiplying it, even though we're multiplying these two values, we're multiplying then a third value by 0. So if you multiply a value by 0, you get 0, nothing happens. But then when you increase the value, say to 1, we now get a deformation, or even 2. But what's happening here is interesting, is that we're actually now beginning to scale the entire object. So yes, we're scaling part of the mesh that's painted with our map, but we're also still scaling or still deforming the rest of the mesh. So we're kind of part of the way there, but still not quite right. So what do we do now to change this? Well, what we do now is, remember, go back to how we're controlling the deformation. This time we're using a weight map. So what it's doing, we're taking all the data from, we're taking all the 400 values of the weight map and putting them into this multiply. Now remember, we want only the white to be applied, but we didn't paint any other colors. We just painted the white color. So that's the problem. We need to go back and paint the weight map again, but this time paint the rest of it black, because it works like a displacement map. The white areas are what gets displaced. The black areas we want to ignore. So in order to control this now, we now need to go back to the color set and use the colors there to control the deformation, because that's what Bifrost is using now to multiply the point normals. It's not using any other values, it's using the actual map data. So we bring up our object, let's bring back our color set editor, and if we bring back our paint tool, we should be able to just start painting black now, and this should actually update. So if we just paint black now, nothing's actually happening there. So maybe let's just go back to this value and lower that down. Oh, there we go. Right, so let's just lower this down to say 0.5. So now if we paint black, there we go, the mesh is updating. And you'll notice that the mesh is updating over here to its original values. So instead of painting the entire mesh, there's a quick way of doing this in the tool, and use the flood option. And what the flood option will do, it will take whatever value you've got here, and then it will, anything that's not been painted already on your map will be flooded. So essentially all these areas here which I've got no values on, I can just flood them like so, and watch what happens when I do this. There, see, the original object came back. So now what's happening is we're using black to define the areas that we don't want to be deformed, and then white to be the areas we do want to be deformed. And of course, if we were to change this and go back to white and start painting, you'll see we can actually paint on the deform. And of course, it's previewing whatever value we've got down here as well. Okay, so that's fine. Now, what I can do is, now I've got two values on the map. I've got black and I've got white. So this basically means that I can now blend between them. And this looks a little bit harsh. So I can soften that slightly by using the smooth option. Let's make my brush a little bit larger and just smooth it off. And you'll see I get a real-time preview as well. I'm just going to smooth this off just to make it look a little bit more visually pleasing, and then we should be good to go. Okay, so that's now just smoothed that off. You can see the preview there. And of course, now with this value, if I just zoom out slightly, we can see that when I drag the slider, we've now got our deformation being applied to our object, but this time the weight map is controlling where we want the deformation to actually occur. So it's almost like a very primitive displacement map, you might say. Now, of course, it doesn't look, it still looks a little bit jagged around here because the original object's subdivision doesn't have enough in there to really support it. But that's just really down to the source object. If I was to strip all this out and add another torus with more subdivisions, then I could equally just pump that into my graph as well. So there we go. That's basically how you can add a simple color vertex map to an object as a property, and then we can get that property into our graph and use that to control our deformation on our object. Now, before we move on and look at the next option for our graph, I want to just explore about what happens if we chose a different type of map and the work you have to do to make that work, because it's slightly different and this could trip some people up. So we know we've got an RGB map here. So if we were to bring back our color set editor, and this time we're going to add another color map, again, we can name it whatever we want. This time I'm going to choose RGBA. So we now have a 4-channel map. So let's just rename it so I know what it is. And this time I'm just going to use the same type of values, but I'm going to just blanket the entire mesh here so the map's very different to the one we actually had already. Okay, that'll do. Okay, so we now have another weight map on our mesh. And again, it's a property, so we can bring that into our graph in exactly the same way. So that's what I'm going to do now. We can use the same node again, so we know how that works. Get GeoProperty, bring in our mesh. This time it's called weight map 02. Let's do this, and what we'll do is we'll just test it out by just replacing this value and plugging it in there. And you do that and it doesn't work. Nothing's happening. And there's no errors being thrown up on the graph. So what's gone wrong here? We've followed the same procedure. We've got a map. We've renamed it. We've painted it with the right values, but it's not working. So what we need to do is try and find out where the problem has occurred and what the problem is and how to fix it. So the first port of call is going to be your watch point. And we noticed that it hasn't actually appeared in our property list. That could be just maybe a refresh thing, because I don't think you can refresh this. So you need to actually remove the watch point and then bring it back. There we go. And then there's our second weight map. So if we look at this, it all looks to be fine. We've got the property name in there. We did name the property correct. And again, we can check the name of it because when we type it in, there's always prone to error. That's fine. But this time, if we look, yes, it's 400 elements. It's an array, but this time it's a float 4, whereas the previous one was a float 3. And there's 4 values because this time we chose a 4-channel map, RGB and an alpha channel. So that's why it's not worked. And the reason why it's not worked is because if you look at these data types down here, the point position and the point normal, that's a float 3. The multiply is using a single value, but it's multiplying by a float 3. The set point position as well is also using the original point positions of the object. So that's also a float 3. So we're trying to apply a float 4 onto a float 3 and it doesn't work. Also, when we went to our property, we set the wrong type. We actually set it as a float 3, and you can see that when I hover over the type, it tells me down at the bottom here. So I've got the data type wrong. I should have specified a float 4. So how do we do that? Because the option's now disappeared. Well, that's really simple. You can just hover over type, right mouse click. Now you can just clear the value, and this will reset that property on the node back to its default value. Or you can just change the value type here. So there, we change it from a 3 to a 4. Okay, so that should work now, right? So now we take this and we plug that in. But this time the object has gone again, but now we've got some error messages. And when we zoom out, the point position is Bifrost is telling us that this is the node where things are going wrong. But the problem is that all these seem to be fine. So why is this going wrong? And if we zoom in here and we hover over it, we get this error message. Now, I'm not going to explain what this error message means because honestly, I can't really decipher it. But again, if you're more experienced in coding, you might begin to understand it. The key thing is looking at the last few lines where it says, this is no promotion exists from a value of type 4, an array float 4 to a value of type math float 3. So again, we know that the point positions are math float 3 array, but we're still trying to use a math float 4. We've got the data here. It's going into the multiply. So Bifrost is multiplying the point normals by this data here. It's then trying to add those values together, which it's done so. Otherwise, we would have got an error. But then when it tries to set those values back onto the object, that's when the error is occurring because there's a difference. One is a float 3 and one is a float 4, and Bifrost doesn't know what to do with it. It's trying to compute it, but it can't. So what do we do to resolve this? Well, we need to somehow convert the float 4 to a float 3. And this is where things can get just a little bit technical, but it's worth doing this because, again, this is another example of some of the core fundamentals of Bifrost, understanding the types of data that go through a graph and what is being expected for some nodes and whether you need to convert them or somehow change them. Now, first off, if we look at this value node now we know that we can bring up a value node and we can set the value type. And we can do this here in this option here under the parameters. And this will give you the ability to change the value type. And also we know from the previous lesson where if we wanted to say unplug this and we wanted to add a value down here, we could right click this and it will create a value node, and it will create it in the format of the original that it's expecting under the previous value. Now, if you notice here, it's created a math float 4. Whereas if we'd actually unplug that for a moment, we'll unplug our float 4 values from our weight map. And this time we'll do the same thing, create value node. It's now created a float 3. And what it does, it looks at the previous port. So in this case, it looked at the point normals and said, oh, you're float 3, I'll create a float 3 value. When we actually had the float 4 values plugged in there, when we did the same thing here, it looked at this data port and went, oh, okay, I'm going to create a float 4 value. Now we understand that behavior, we can now look at the actual node itself. If we go into the property here, there's a few options here. And again, you may not understand what half these mean, but again, this is where Bifrost can kind of help you. There's 4 tabs here. Now, it could have gone to any one of the 4 tabs, but it went to the vector tab. And you notice here, it's telling you what type it is. And there's an array button here as well, which is unchecked, interestingly. But this is just a value node. It's just giving you a float value. It's not an array node. But you notice it's gone to the vector tab, and there's some components here, and it's on option 4. If we were to cancel this and bring up, say, unplug that for a second, and unplug that. Let's bring back the float 3 value, do the same thing. That's gone to the vector tab again, but this time it's chosen 3 because it's a float 3. So we can decipher this and put this together with some simple logic and say, well, basically, this is where we change the values from a vector 3 to a vector 4, or 4 to a 3, and it's a vector. Now, I'm not going to explain what a vector is, and you may not even know what a vector is, but all you do know is that Bifrost is telling you that it's vector values and it's a float 3 or float 4 or whatever. So with that in mind, we can now try and apply that to some kind of conversion. And what we need to do, we need to somehow take the vector 4 here and convert it into vector 3. And then that way it will go into the node, and that way it should hopefully flow through the rest of the graph, and we shouldn't get any of the problems. But then how do we do that? Well, again, we can try tabbing a node in and see what happens. So we go to tab. Now we put in conversion. That doesn't seem to work. Now if we put in float, we don't get any nodes there either. But we know, remember, it was a vector. So let's try vector. And now we get something worth looking at. The name of the node actually provides the description of what it does. So a vector 2 to scalar, a vector 3 to scalar, vector 3 to vector 4, vector 4 to scalar, and then a vector 4 to vector 3. So this choose vector. We know we got a vector 4. So if we chose vector 4 to scalar, what does that actually do? Well, we can see here and look in the info panel. This splits a vector 4 into its scalar components. So you can see the input is the source of vector 4. So if we took the data here and put it into there, what this does, this splits out the vector 4 into its 4 channels, X, Y, and Z, or in our case, R, G, B, and alpha. So in theory, what you could do, what would happen if you took one of these and plugged it into here and try it out? Look, and that's kind of worked. That's actually given us what we want. That's given the deformation. And if we were to bring in this node here to control it, what does that do? It's gone back to 0. So now if we drag it, so that's kind of working. Now we only plugged in one channel there. Do we not need all the other ones? Well, we're only dealing with a simple black and white map. So of course it's reading one channel, and with 2 extremes of light, 0 with black and white, any channel is going to work really, red, green or blue. It doesn't really matter. So you could just leave it at this. You might be thinking, well, that's fine, but what do you do if you've got actual 3 colors on a map? If you've got 3 separate RGB values, you're not just using black and white, then you're going to need all 3 channels. So this time you choose this node, which was the vector 4 to vector 3. And what this will do, this will convert the vector 4 to the 4 channel to a 3 channel, but it will split off the alpha here. And then instead we can put that in there and we still get the same result. But this time we're using all 3 channels. So we're making sure that all 3 channels worth of data is going into our multiply node. So this is an example of what can happen when you try and put certain type of data through a graph and it's just slightly incompatible. Bifrost will throw up an error and then you're going to have to decipher it. And then just by looking at the properties, looking at the data types and understanding kind of the basics of what they are, you can then begin to think about how to change them and convert them. And then what we've done here is, in this case, we had a vector 4 map and we've multiplied it, or we've actually converted it from a vector 4 to a vector 3. And then we've taken that vector 3 and put it into our multiply, and it's worked no problem. And you'll notice that the alpha channel is still separate. So we could do whatever we want to this. We could put it into whatever node we want if we want to do something else with it on another type of deformer or another type of effect, whatever. We split it off. But of course, you can still do it this way. You could decide to maybe separate all 3 channels out as well. So it's worth looking at these conversion nodes because they really are very, very handy when trying to convert one type of data to another. So that was an example of how you bring in a different type of map into your graph, and then how you have to just make a few changes in order for it to work and also be applied to your mesh, and you can then perform the deformer function in the same way. Now, what do you do if you think to yourself, well, I want to have both types of maps on my deformer? What if maybe I package this up into a compound and my end user wishes to have the option of being able to choose for an RGB map or an RGBA map? I don't know what my end user is going to need, so I'd like to give them both options. So how do we do that? Because obviously we can only do one function at a time. We can't have 2 deformers going off on the object at once. So what do we do now? Well, this is where you bring in an if node, and this is a really powerful node in Bifrost because it allows you to control the flow of data through a graph through basically 2 different inputs. Now, again, you're not going to know this if you don't have any concept of it. But again, I'm cheating it a little bit because I wanted to always do these videos on the assumption that you don't know anything about scripting or programming. So I'm being a little bit naughty here, but it's really the only way I can really explain it. But the if node is very common if you're used to working, say, in Excel, for example, or any kind of other spreadsheet based package where you put in a formula into a cell to say, well, if the value of the cell is this, then add it to this cell value. Or if you're used to working with expressions, for example. And we find that if node by literally just typing in if, and it will come up here. And there's a little bit of description here, but I liken this to something like a light switch. And the idea is you have a condition. So the condition controls which value is being processed because we've got a true and a false. Now, don't be misled by the name in here. That's just what it's called now. The true and false could be on or off, left or right, 0 or 1, whichever is basically 2 extremes. And the condition is like a light switch. If you turn it on, it will use the true option. If you turn it off, it will use the false option, or whatever value you've got here. And that's all you've got. These ports are just values. But of course, you can specify a value, or you could actually because they're ports, you can put a graph into these ports as well. And it's a very simple mechanism, for example. Now, we'll use this value node to give you an example of what I'm talking about. So this to say we unplug this and we plug in this node instead. And it's set the true case to say something really extreme. So we'll choose 1 and then the other one will choose 5. Now you notice how I changed that straight away because the condition is set to off, which basically means it's using the false port, which is 5. If I turn it on, it will use the value of 1. So this will give you, that's the really basic primitive example of how this if node works. So we're just flicking between 2 different values. So now we understand that basic principle, we can apply this to our maps. And in this case, we can apply it to 2 different weight maps. So what we're going to do, we're going to replace that there. So what we want to do now is say, okay, let's bring in the if node now and say, okay, we want to, for the true port, we want to use an RGB map here. And then for the false port, we're going to use the vector format. But remember, we don't want to take it from here. We want to take it from here because we need this node to do the conversion from the RGBA map to an RGB map. So in this case, we're going to take it from there and plug it into there. And now we've got this plugged in, we can take this and plug it into here, like so. So now with the if node is controlling which map we choose. So at the moment it's set to true, so we're using the RGB map. And if we bring back our value, we can see that. So there we go, that's using the RGB map. And if we flick this to off, it's using the RGB A map. So that's how we've introduced the option of being able to use two different types of maps on this same object. So now that we have this, we can package this up into a compound. So let's do that now. So what we could do, we could expose the ports now if we want to, or we could simply compound it up and then do it. But it's really entirely how you want to work. But again, if we just took all of these, right, compound, and they've got everything all wrapped up into there. So now we go into that compound and say, right, okay, what do we want to plug into our input? So first of all, we want to maybe have, we want to bring in these properties. So we want to bring in this one here. This is going to be our RGB map. But of course, we're going to want to rename this because otherwise the user won't know what it is. So we'll just rename this port and call it RGBA. No, RGB, sorry. Then we'll bring in this one here, which is our 4 channel, which in this case, this will be our RGBA. We want to bring in the value, so we know the amount of deform, so we'll put that there. And of course, we're going to want to have the condition, the switch. So let's bring that there. And we'll rename that as well. We'll just call it, map type. But actually, we want to put that at the top, so we can just move the port to the top. So that'll be the first thing you choose, essentially. Actually, just move the port down so the mesh is the first thing. So when we go back out, that's our compound. So we pump in a mesh, we define the map type, and then the RGB and the RGBA, we specify the name of the property that you've got on your mesh. This could be anything. It doesn't have to be weight map 01. It's just saying that because that's what I've got applied on my mesh. But if I package this up as a compound, then eventually the user who takes this, they can create whatever map they want on their mesh and name it whatever they want. As long as they put it into the right field, the effect will be applied. And there we go. So we've got a nice, like a hybrid compound there. And of course we can use to publish this, and we've got now a new deformer, which is basically built upon our original deformer, where we instead of being applied over the entire object, we can now apply it using the weight map. Okay, so I've just done a little bit of tidying up. This is my new published compound, my new deform by weight map. You can see I've got the same types of controls. Again, this will work in exactly the same way. I've also brought in my original push deformer as well, so we've got that working as normal. And again, we can actually choose to use the weight map one instead. So I'm just going to plug that in there. But of course, it will go off because I don't have anything plugged in. So I need to just type in the name of the weight maps, 01. There we go. That still works, the value, and then put this one 02. So we've got that basically working. And as long as you specify the weight map name, it will work. So now we've got this working, we've got 2 deformers. Again, we've got the option now to choose or bring in the if node again. And so, well, actually, I now want to bring in I want to create a whole new compound, which is utilizing both types of deformation. So I've got 2 compounds. One is an object deform, one is a weight map deform. Again, I can do the same thing. So let's bring in our if node and say, okay, this apply the same logic. So the false will be the weight map, the true will be the object deform, and then the output will go here. And this way I should actually, this should work now. So let's just true. And again, I'm deforming by object, go to the condition, turn that off. And I'm using now a weight map deformer. And as I did before, I could take these three now and then create another new compound. And again, I can do the same thing here and expand this out into another type of deformer. So again, I can just plug these ports in here. Don't even have to change the names because it will retain the names. Plug them all in here. And I've now got an entirely new compound. And now we've got this compound created, this new compound, we can retrieve in our other ones as well. So we've got our standard deform by weight map, and we can also bring in our original object deformer as well. So again, we've got three types of deformer. So remember, over the course of these three videos, starting by creating a very simple push deformer, we've created not one but three different types of tools. Now, I know they're not the most exciting tools and not the most exciting features, but it's all about just demonstrating what you can do with Bifrost just by starting with a very, very simple effect and creating a compound. We can expand it into three types of deformers, which you can then also, I could take all of these and compound them up into another one as well. So again, this really demonstrates the power of Bifrost and how you can quickly build up these tool sets and build them up for your own usage, or package them up and distribute them to other users as well. Okay, so we've now reached the end of the video. I hope this has been really useful for you. I hope you've been able to watch my previous two videos, and together with this video you now have a good understanding of the Bifrost graph editor and how to actually use it. And hopefully now, if I've been able to explain it correctly, that you've now got some basic knowledge so you can now start experimenting yourself in Bifrost. If you think you're ready to proceed to the next level and you want to try something a bit more advanced, I'll include some links to some video tutorials in the description below. There's some really good stuff out there by some really clever people, so they're really worth checking out if you're ready for it. If not, then stay tuned to my channel and I'll be hopefully trying to do some more Bifrost content soon. And as always, as I've done with these videos, I'll always try and assume that you've got no programming knowledge whatsoever, and I'll aim these videos at the non-programmer, non-TD, because if you don't have that knowledge to begin with, then you perhaps might struggle. But my aim is to try and get you guys into Bifrost so that you can start using it yourself. Thanks for watching, and I'll see you in the next video.